folks, this is going to be part 2 of the series for our Unit 7 in Precal and Unit 5 in Geometry. So what we have here is we're going to do solving oblique triangles using law of sines. And this is going to be useful if we're given like an angle, side, angle, angle, side, which are basically the same thing. And we're not going to spend a whole lot of time. Actually, I'm just going to briefly mention side, side, angle. I have a separate video on that. Okay, so let's go ahead and get going. So deriving law of sines, since I'm probably not going to do this during the live Webex lesson, but I do want to cover it for this video. So the law of sines is based upon the area formula, okay, area of the triangle using the side angle side formula that I covered in the last video. So let's take a look at this. If we have sine of A, here's A, it's h over b. So sine of A is equal to h over b, okay? Now let's go ahead and solve for h. So we're going to multiply by that. So h is equal to b sine of A. All right. We could do the exact same thing for this over here. And so we have sine of b is equal to h over A. All right. Solve for h, and we're going to have h is equal to A sine of b. All right. Well, if this h and this h are the same, guess what we have? We can use substitution and put this in for h right here, okay? And one reason why you study substitution in algebra is that we can have a sine of b is equal to b sine of A. And when I divide, or there's several different ways I can write this. I could divide by b on both sides. I could divide by a. But I'm going to get basically sine of A over A is equal to sine of B over B. And I could do the same thing for the C right here, and I'm going to get sine of C is equal to over C. So what we have is proportions here. So we're going to take any two of these. We're going to have three knowns, one unknown. It's called the rule of threes from the 19th century. And solve for the missing one. And it's actually a pretty easy, fun little formula. So let's go ahead and see how that works. Typically, you very often see it like this. All right. And there's really cool. In geometry, in my advanced geometry classes, we actually explore the relationship of the law of sines and the diameter of a circle. There's a lot of really cool stuff that goes on with this. And remember, the diameter of the circle is actually a hypotenuse of an inscribed right triangle. Lots and lots going on here. But so this is mainly for my advanced geometry, Precal, and everybody else. You don't have to worry about it. Okay, so when we go on, we're going to just use something that looks like this. And let's go ahead and just do this examples. You don't have to draw the triangle, and the triangle just can be some utility. Here I have basically an isosceles looking triangle. It doesn't matter. But if you do draw one, let's be consistent. Let's call this A, let's call this B, and let's call this C. All right? Now these are big capital letters. That means opposite is a little a, opposite B is a little b, and opposite over here is a little c. And we're going to solve for what we know. So we have 28.7 right here. 28.7 degrees here. C is 102.3. And B over here is 27.4. So if you know two of the angles, all you do is just subtract from 360 to find your other one. That's all you have to do. And when you do that, you get 49 degrees. So this is just 49 degrees right here. So this is just 49. Okay? So I could do sine of A over A is equal to sine of B over B. And might as well just do that. Okay? So I'm going to have 27.4. That's B over sine of B, which is 28.7. Sine of 28.7. Make sure your calculator is in degree modes. Again, this is largely geometry, and we do things in degrees in geometry. And then we have A over 49 degrees. Okay? A over sine of 49. Do a little cross multiplying, and you're going to get A is equal to 27.4 times sine of 49 all over sine of 28.7. You just multiply that across. All right? And you're going to get about 43.1. All right? So that's what A is, for about 43.1. You do the exact same thing for B. Define side C. You're going to do sine this over that is equal to any one of these, sine of this over that. Now, a lot of teachers like to put the sides over the sines, and it doesn't matter to me. All right. There's reasons for both as far as ease of algebra. So let's go ahead and find the other part. So I'm going to just go do 27.4 over sine of 28.7. Okay. That's sine of B, 28.7. I could have used the other one. Rule of 3, you're allowed to do whatever. So I'm going to have C over sine of 102.3. When I cross multiply, C is going to equal to 27.4 times sine of 102.3 all over sine of 28.7. Okay, and that's what I put in right here. So this is finding side C, and you get 55.75. All right, okie dokie. That was angle, angle, side. If I did angle, side, angle, I could turn this into an angle, angle, side. Again, these are corollaries of each other. If you remember from geometry, if you have angle, angle, side proof, you can turn it into an angle, side, angle, triangle proof. Alrighty, so what we have here is, and again, I could label my triangle, and to be consistent, I have A, B, and C on top. That little a, little b, and little c. And I could just fill in what I know. But I'll just go ahead and do that. All right, so A is 43 degrees. B is 98. I can automatically find C by subtracting from 180. C is 22. So if I want to find A, I could just do A over sine 43 is equal to, well, I'm going to need to find C, won't I? So C is going to be 39 degrees because I subtract. Then I would do 22 over sine of 39. Now I think that's exactly what I'm going to do. I'm going to find A first. I could have found B first. Sine of 43 is equal to 22 over sine of 39. All right? Do a little bit of cross multiplying. Basically, you multiply by sine of 43 on both sides. So you can have A is equal to 22 sine 43 over sine of 39. Put that in the handy dandy calculator, and you get 23.8ish. Okay? You're going to rinse and repeat to find the other side. And you should be able to pick up speed on these. These should go pretty quick. 22 over sine 39 is equal to B over sine of 98. Cross multiply, solve for B basically, and you have B is equal to 22 sine of 98 all over sine of 39. Toss that in the calculator like I did here, and you get 34.6. Okie dokie. So I think that is it. Do I have any more? Oh yeah, I want to briefly touch on ambiguous case. So this is for side, side, angle. And you need to test, but you don't have to test every single side, side angle if you have some rules memorized. You should be dealing with an acute angle, this angle being acute, and the opposite side needs to be less than the adjacent side. Again, check out the video, and in these notes toward the end, I'll show you real quick. I have all the side, side angle stuff going on here, and this is what I was talking about just now. So these will be PDF'd into your notes on Canvas, and this is an example of one worked out. So normally in the classroom you would have had one of these on your test, but you get a pass on that. All right, and again, this is primarily geometry. Okie dokie. So let's go ahead and get ready for law of cosines on the next video.